what do we do if we have to add several? That's what we have to do. We just have to repeat the same rule as many times as we need. For example, a plus b plus c. First we can do a plus b, and then we can apply the tail to a head rule to add the third vector if we need the fourth, the fifth. And then we can always draw the resultant. The order of addition doesn't matter. A plus b plus c, b plus a plus c, c plus b plus a, c plus a plus b. Well, anyway, same thing. If we want, we can measure its magnitude, and we can measure the angle. However, if we want, we can use components. This combines everything, and subtraction. Well, first of all, we don't have a special rule for subtraction. So we have to convert subtraction into the addition. And that's how we do that. We introduce the vector which is opposite. We call it minus or negative b. The vector which is opposite to the given one must have the same magnitude but opposite direction. That's why we call it opposite. So now with this definition, subtraction is a very simple procedure. Let's not use the component method. Not time. Let's do this. Let's use the definition. So a minus b. That is literally a plus opposite b, or negative b. So do we have a vector a? Well, that it is, a. Do we have a negative b? Not yet. So what do we have to do? We have to draw it. By a definition, it must have the same magnitude as b, but it has to be opposite to it. So that's negative b. So now, a plus negative b is literally this plus this. We have to use a tail to a head rule. So I want to redraw negative b from the head. That's negative b. I don't see the resultant yet. Well, this is a plus negative b. Start, finish, start to finish. That's the resultant. That's what we call R, which is a plus negative b. Or just a minus b. Any questions? So whenever we need to subtract vectors, we convert subtraction into an addition. And we know everything about addition now. So if we have to calculate, for example, the magnitude of this resultant, this doesn't look like a right triangle, so we have two options. Again, number one, we can make as many right triangles as we want to by just drawing a perpendicular. And option two, we can use another math, and it's up to you, whichever is easier for you, whichever you like more. As we remember, we also have two theorems in math, sine theorem, cosine theorem. So for example, if you have a triangle like that, and if you know this angle and these magnitudes, the cosine theorem immediately gives you the magnitude of the resultant. What else could you do? Use components, as a couple of slides before. What do you want to do? Nobody cares, it's up to you. I would recommend trying both and see for yourself which will give you the faster result. which you're more comfortable with using. That's it. How would you arrange those vectors in order to achieve the resultant with the maximum magnitude, or in order to achieve the resultant with the minimum magnitude? So 4 possible questions. Let's choose one, for example, 3, 4, 6. Case number 1. Magnitude of A equals 3, magnitude of B equals 4, magnitude of, well, let's say C equals 6. And the question is, how would we arrange those vectors so the resultant would have maximum possible magnitude? A. B. C. So it's up to you how you point them, how you arrange them. So what I can do, I can actually just play with these 3 vectors. What does each vector miss? Yes, so I need it, of course. Now, well, let's say A plus B. That could be my A plus B, and that could be my A plus B plus C. What would be my resultant? Well, can I make it any longer? Yeah. So how? For example, like this. That will be my next resultant, longer. So if you want to achieve the maximum resultant, how do you align them? That's very simple. They just have to be all pointing in the same direction. That will give you the maximum possible resultant for these 3 vectors. That's a very straightforward question. But how would you arrange the same 3 vectors now if you want to achieve the resultant with the minimum possible length, with the minimal possible magnitude? How would you draw the picture to answer the second question? Any suggestions? Minimum, yes? You want to make a triangle. Something like this. And why do you think that gives you the minimum possible magnitude? I can rotate. And? Perfect, absolutely right. Actually, that's the first time when I got this answer from the audience. The smallest value for the magnitude is 0. That's what we are looking for. If it's possible, make a triangle, we make a triangle. In that case, this plus this plus this, start and finish, it's the same point. There is no distance between start and finish. That's a 0 vector. It has no magnitude. A, still 3 meters. B is still 4, but now C is 8. And now, again, let's looking for the minimum, because we know how to find the maximum. How would you rearrange these vectors now to get the resultant with the shortest, smallest length, smallest magnitude? This C doesn't work anymore. We need a new C. Don't look at me. Do your part. Why I'm doing that? To show you that you can do the same whenever you have a question about vectors and you feel confused. So, well, a question to everyone. With these magnitudes, is it possible to make a triangle? No. So, if it is possible to make a triangle, you can make a triangle that will give you 0 magnitude. But if it is impossible, what do? How will you arrange them now?
As close as possible to a triangle.
You just make it close as possible to the smallest result by using negative vector.
Well, in physics, we call them canceling out. We want them cancel out each other, if it's possible. So, and there are several possible combinations you can try. Something like that, for example. Any questions? Yes?
How do you know it's impossible to make a triangle?
Good question. Anyone? Yes?
Don't the two smaller sides have to be, if you add them together, they have to be?
In every triangle,
Or they have to be greater?
A, B, C, yes, A plus B, magnitudes of A plus B, magnitudes has to be greater than the magnitude of C. If A plus B is equal to the magnitude of C, A, B, C. This is kind of your triangle. And if A plus B is less than the magnitude of C, that's it. It's impossible to form a triangle.